For most objects that enter our solar system, tracing their origin is simple geometry. Plot their trajectory, wind the clock backward, project the curve across time and gravity, and you'll usually find the birthplace, a region near the Oort cloud, or maybe a dense corner of the Kuiper belt. But 3I Atlas doesn't follow that script. When it passed Earth, astronomers expected a typical hyperbolic path, the kind any natural interstellar object would travel, fast, untethered, fading into darkness. But as observatories compiled the full arc of its journey, from first detection to post-perihelion drift, something didn't add up. The numbers didn't behave. The exit velocity wasn't just high, it was refined. And that refinement, that unnerving precision, forced a question few dared to ask out loud. What if this trajectory wasn't an accident? Using advanced orbital modelling, data analysts at NASA's Jet Propulsion Laboratory attempted a full reverse projection. They fed the complete observation set into the system. Pre-perihelion data, solar wind interactions, magnetic field deflections, and the unexpected course correction that occurred just after it left the Sun's influence. Then they asked the software to run the timeline backward. 100 years, 1,000, 1 million. Instead of dispersing into statistical noise, like most trajectories do when pushed far enough, the curve of 3I Atlas stayed consistent. It tightened, it narrowed, and it pointed. Not toward the galactic core, where stellar birth is dense and chaotic. Not toward known systems catalogued and glowing, but toward something else. It pointed to a gap, a cold region of space between Cassiopeia and Perseus, known among deep sky observers as a null corridor. It's not entirely empty, nothing in the universe is, but it's eerily underpopulated. No known star-forming regions, no active nebulae, no high metallicity systems with planets, just the residue of old radiation and a background signal that has puzzled microwave telescopes for decades. A soft distortion, a low hum, a wrinkle in the data. That's where the models pointed. Not vaguely, not approximately, precisely. To astrophysicists, this created a paradox. If 3I Atlas was natural, it needed a birthplace, a gravity well to escape from, a stellar nursery to form in. But this region had none of those. There were no gravitational interactions recorded in its past, no slingshot maneuvers that could explain its current speed. If anything, the data suggested 3I Atlas had been coasting, uninterrupted, for millions of years, straight, clean, silent. And yet its path wasn't quite inertial. It had minor corrections, subtle nudges, course shifts that didn't align with known gravitational disturbances. That's where the questions multiplied. Was it reacting to something in space, or had it been aimed from the beginning? One team from the European Space Agency's Orbital Mechanics Division proposed a theory, not a proof, just a possibility. They called it intentional vectoring. The idea was radical. What if the current trajectory wasn't a result of natural forces but of origin itself? What if the object was launched, and not ejected, by some system long ago with one intent to arrive here? The backtracing isn't conclusive, but it's haunting, because it lands us in a region that shouldn't produce anything, but now, possibly, has produced the most confounding object we've ever observed. And that's where the trail leads, into a dark, silent patch of sky, one that's been ignored for decades, one that now glows with a new kind of significance, because something came from there, and it may not be the last. When astronomers trace an object's path across the stars, they don't just look at where it's going, they look at what it's leaving behind. For 3I Atlas, that trail leads to one of the quietest, most mysterious sectors in our galaxy, a stretch of space that, until now, hadn't given scientists a single reason to care. This area, between the constellations of Cassiopeia and Perseus, has no official title, no nickname from ancient sky watchers, no buzz among exoplanet hunters or radio astronomers. It sits between fields of star-forming gas and open clusters, but does not participate in either. When researchers pulled up maps of its energy output, they found only silence, low electromagnetic activity, no ionized gas, no spinning debris disks, no planetary signatures. It's what some call a null corridor, a place where the galaxy seems to have fallen asleep. And yet, that's exactly where 3I Atlas came from. When analysts at multiple space agencies followed its inbound path and plotted the return vector, the orbit stabilized in this region. That by itself would be strange. But there was something else buried in the historical data, something long ignored. Back in 2009, a team studying the cosmic microwave background noticed a faint irregularity in this exact zone. It wasn't a signal, exactly, more like a shadow in the noise, a subtle distortion in the low-frequency microwave band, the same region of space where the ancient afterglow of the Big Bang should be smooth and featureless. But here, it wasn't. A ripple, barely measurable, then gone. At the time, it was dismissed as instrumentation error, but the coordinates stuck. Fast forward to today. That same spot in the sky is now being re-examined under a new lens, not because it suddenly got louder, but because of what just exited it. The idea of a cold launch corridor is emerging, a zone of space not defined by activity but by absence, a place that hides trajectories, that masks origins, that keeps the signature of motion so low, so quiet, that nothing seems to be happening, until something emerges at extreme velocity. That's exactly what 3i Atlas did. It appeared, silent, fast, precise, and headed straight for our solar system. What makes this more troubling is the pattern of approach. Its angle of descent was not random. It bypassed the outer planets. It didn't swing by Jupiter for speed. It didn't take the chaotic curve of most interstellar comets. It avoided every major gravity well until it neared the Sun, as if it were avoiding disturbance, as if it needed to maintain course integrity. That's why this unnamed region is now under scrutiny. Astrophysicists have begun referring to it as the launch quiet, not because we've detected a launch site, but because its properties allow objects to emerge without signature, without detectable thrust, without a flare or heat or noise. It's the perfect blind spot. The question becomes, is it naturally quiet, or deliberately so? Radio observatories have turned their attention there again, this time not for broad-spectrum listening, but for structured silence, places where signals should exist but don't. That kind of negative data is harder to analyse, but it's also where the most advanced signal work begins, because what's missing might matter more than what's present. If 3i Atlas came from here, a place devoid of stellar formation, devoid of debris, devoid of heat, then it's not a birth site. It's a transition point, a gate, a corridor. It's not what's in the region that matters, it's what comes from it. And if something else emerges from that same void, something with the same precision, the same silence, we may have to admit that we've found a place that doesn't just exist in space. It operates in it. 3i Atlas may be the third confirmed interstellar object to visit our solar system, but its arrival didn't occur in isolation. It follows a pattern, one that began with confusion, escalated with contradiction, and now circles back with eerie precision. It started in 2017 when Oumuamua came in fast, spun oddly, and left faster. That object tumbled in a way no natural body ever had. It showed no outgassing, no tail, no signs of sublimation, and yet it changed trajectory. Quietly, without spin, just like 3i Atlas. Then, in 2019, 2i Borisov arrived. This one looked more familiar. A glowing coma, a long tail, an outgassing profile that felt reassuringly comet-like. Astronomers exhaled. Maybe one Oumuamua was just weird, an edge case, a fluke. Borisov let the scientific community return to known physics. But now, with 3 Atlas, the pattern has cracked open again. And this time, something is different, not just in behaviour, but in origin. When orbital analysts laid the paths of all 3 objects side by side, they noticed something no one had seen before. The entries weren't random. They were spaced across time, but not across space. All 3 arrived on trajectories that intersect the same corridor, that quiet region between Cassiopeia and Perseus. Slightly offset, spread across angles, but aligned in galactic context, not clustered, sequenced. If you plot them backward in a 3-dimensional map, a kind of lattice emerges, a directionality, one that implies not just shared origin but ordered movement, as if something released them in stages. First in 2017, then 2019, now 2025. Each one closer, each one more detailed. Each one more interactive with our solar environment. Some researchers call it coincidence, others are no longer convinced. Because when you compare the anomalies across all three objects, a structure begins to form. Oumuamua showed anomalous acceleration but no emissions. 2I Borisov showed emissions but no anomalous acceleration. 3SK Atlas shows both, and something else, responsiveness. It responded to solar forces, not passively, like a snowball reacting to heat, but actively, like a body adjusting itself, reflecting light differently, changing direction without tumbling, altering velocity not in bursts but in arcs, smooth arcs. And then there's the timing. 6 years separate the first and third interstellar objects. Not centuries, not millennia. 6 years. In cosmic terms, that's a blink. And yet, within that blink, we've recorded 3 events from outside our solar system, after millennia of none. This surge in activity raises a simple question with a complicated answer. Why now? Some astrophysicists speculate we're just better at spotting these things, that improved sky surveys and broader monitoring have opened a floodgate of detection. That's partly true, but here's the problem. Sky surveys don't detect what's not there. And these 3 objects weren't just detected, they stood out. Because they didn't act like the comets we know. They act like messengers, each more articulate than the last. And now, some believe they may have been testing something, mapping gravitational influence, measuring solar output, recording electromagnetic conditions. 1 Oumuamua passed quickly with barely any data. 2I Borisov lingered longer, gave us more to see. 3 Atlas stayed even longer, and did something entirely new. It left behind emissions, fragments, and signatures. It gave something. That's not a comet behaviour. That's a behaviour of progression. The idea is uncomfortable, but it's gaining ground. Because what we once called the first visitor may now look more like the first scout, and the third, a probe that stayed to listen. What will the 4th one do? Not all evidence arrives through motion. Sometimes the most revealing signature an object can leave behind is its chemistry, the invisible trail encoded in light. And when astronomers turned their spectrometers toward 3I Atlas, what they saw broke more than expectations. It began with infrared readings. The James Webb Space Telescope, perched far from Earth's interference, locked onto the object's coma, the glowing shell of gas and dust surrounding its icy core. These emissions are fingerprints. They tell you what's being released, how fast and in what proportions. For decades, astronomers have catalogued thousands of cometary compositions. Most look the same. Water dominates, followed by carbon monoxide, some trace carbon dioxide, dust grains, and a range of minor volatiles. But 3I Atlas flipped the ratio. Instead of water dominating the signal, it was carbon dioxide. Not just slightly, overwhelmingly. The ratio between carbon dioxide and water wasn't 1.1. It was more than 8.1 in some observations. That's unheard of in solar system comets. Water ice forms abundantly in our system's outer regions, and it vaporizes easily under sunlight. Carbon dioxide is usually just a side product. But here, it was the main act. That single fact, the CO2 dominance, told scientists that 3I Atlas didn't form anywhere near our Sun. It came from a system with entirely different conditions, a place where water was rare, a place colder, darker, or governed by a different stellar chemistry altogether. But the clues didn't stop there. Alongside the carbon dioxide, researchers detected other strange markers. Elevated levels of carbonyl sulfide, a molecule not commonly seen in solar comets. Organic compounds that appeared partially fractured, as if exposed to radiation fields stronger than anything in our own neighbourhood. Trace hints of nickel, not in dust, but in vapour, suggesting it was being released, not just carried. These details don't just describe what the comet is made of, they describe its history. To survive the interstellar medium, an object must endure radiation, temperature extremes, and collisions with micrometeoroids. But 3I Atlas didn't just endure, it evolved. The molecules in its coma were altered in ways that suggest long-term exposure to galactic cosmic rays. Some of the simpler organics had fragmented into chains never before catalogued in a comet. Others had fused into heavier, more stable compounds, the kind that don't form naturally in comets, but do under repeated high-energy bombardment. This wasn't just chemistry, it was processing, as if the object had been engineered by its environment, or perhaps by something more deliberate, to survive, adapt, and arrive intact. Even the water molecules detected carried a hidden anomaly. Their isotopic composition was off. The deuterium to hydrogen ratio was higher than any known comet. This ratio acts like a birth certificate. It tells you where the water was formed, how cold, how old, and how different the environment was. In the case of 3I Atlas, the signature placed it far beyond even the coldest regions of our own system. This was alien ice. Water not from here, not even from near here. Put all of that together, the CO2 dominance, the strange organics, the exotic isotopes, and you get one undeniable conclusion. This object was not made in our neighbourhood. It came from a system whose chemistry we don't understand. It formed in conditions we don't replicate. It carries with it a chemical library that doesn't match anything we've catalogued, and that makes it more than an interstellar visitor. It makes it a message, not in words, but in atoms, because where it came from, things are different. And what it's made of may tell us more about that place than any photograph ever could. If light tells us what a comet is made of, isotopes tell us where it was born. Every star system leaves a signature, a subtle ratio of elements shaped by its local chemistry, age, and radiation environment. These ratios don't lie. They're not distorted by motion, heat, or interpretation. They are locked into the molecules themselves, embedded in the nuclei of atoms. And when scientists looked closely at the isotopic fingerprint of 3I Atlas, what they found was unlike anything we've seen in our solar system, or anywhere near it. The most revealing ratio is between deuterium and hydrogen, a heavy isotope of hydrogen and its common counterpart. In water molecules, this DH ratio is a cosmic birth certificate. It tells you the temperature at which that water formed and the kind of star that radiated nearby. Comets in our solar system tend to have similar DH values, suggesting a common origin, the cold outskirts of the solar nebula. But 3I Atlas wasn't just different, it was wildly different. When the hydroxyl, OH radicals in its vapour were analysed, the deuterium content was found to be among the highest ever recorded. In some measurements, it was more than 5 times the average value seen in solar comets. That number can't be explained by noise or margin of error. It places the water in 3I Atlas at a formation temperature lower than anything expected near our Sun, or even most known stars. To put it plainly, the water in this object was born in deep, deep cold. Colder than the Kuiper belt, colder than the Oort cloud, possibly in a system whose central star was faint, slow-burning, or long dead. And this wasn't the only anomaly. Carbon isotopes, specifically the ratio of carbon-13 to carbon-12, were also skewed. The value matched no known reservoir in our solar system. Oxygen isotopes hinted at processes involving supernova remnants, material shaped in the aftermath of stellar death, then compacted into dust that eventually became ice. This suggests a multi-generational origin, not just a young system but a recycled one, built from remnants of older, more violent stars. Even the nitrogen-bearing molecules in the coma had isotope ratios consistent with interstellar dust clouds observed far from Earth, clouds where star formation has long since ended and only drifting gas remains. The implications are staggering. This wasn't just a visitor from another system. It was a traveller from a different kind of system, a place whose isotopic chemistry tells a story of extreme cold, cosmic violence, and ancient age, a place where molecules formed slowly, in silence, under very different rules. One of the most striking moments came when a lab in Japan compared the isotope profile of 3I Atlas to that of known carbonaceous chondrites, meteorites believed to be some of the oldest materials in the solar system. The difference was immediate. 3I Atlas was more enriched in heavier isotopes. That means it spent more time exposed to radiation, more time in the deep void, and perhaps more time being prepared for travel. Because these isotopes don't just describe material, they describe intent. The water in this object wasn't temporary, it wasn't fresh. It was ancient, preserved, protected, either by thick outer crusts or, as some now suggest, by an internal regulation system that slowed evaporation, reduced damage, and maintained molecular integrity during the journey. That kind of regulation isn't chemistry, it's structural, and when every isotope points to deep space, long duration, and engineered preservation, then you have to start asking, was this object meant to survive the journey? Because isotopes never lie, and this one says 3I Atlas has been coming for a very, very long time. Most comets enter the inner solar system trailing chaos. They tumble erratically, they spew jets of gas that alter their spin, they react violently to solar winds, their surfaces torn by heat, their structures fragile and frayed. But 3I Atlas didn't. It behaved like it had a plan. The first sign came during perihelion, its closest approach to the Sun. Instruments from NASA, ESA and independent observatories were watching closely. What they expected was jitter, a wobble in spin rate, the usual chaos of a comet under solar pressure, but instead 3I Atlas held its orientation, it maintained trajectory, and most importantly, it responded. When solar wind density increased, it shifted. When electromagnetic flux spiked, it reacted. Not randomly, but in perfect rhythm with the fluctuations. It adjusted with timing that wasn't lagged, as natural bodies tend to do under heating. It adapted in near real time. This was the moment when some scientists began whispering about magnetic memory. To understand that term, you have to step into the physics of materials. Magnetic memory refers to a material's ability to retain an imprint of magnetic fields it's interacted with, to respond to those fields consistently over time, as if it remembers them. Most rocks don't do this. Most dust grains don't either. But certain alloys do. Certain metals. Certain materials with structure. The Parker Solar Probe passed near the region shortly after 3I Atlas's closest solar point. Its instruments detected something strange. A wave of magnetized particles had been distorted, bent around a region of space where nothing should have been strong enough to interfere. A faint deflection, measurable, momentary, centered on 3I Atlas. In the hours that followed, Earth-based observatories confirmed something else. The object's trajectory had subtly altered. Again, and again, it wasn't due to outgassing. There were no jets. No torque, just a clean vector adjustment, almost like a sail catching wind. Except this wasn't wind, it was solar magnetism. The implications are profound. Because to respond to a magnetic field without being torn apart, an object needs stability, structure, conductive materials. It needs surfaces that allow current to move. And in 3I Atlas, the response was more than passive. It was coherent. It curved into the field rather than scatter within it. It rode the distortion instead of breaking under it. When ESA's solar orbiter reanalyzed the polarization data from its earlier flyby, they found a signal consistent with structured reflection, not diffuse like ice or dust, but organized as though bouncing off a smooth or compact surface. Combined with the magnetic data, a new picture emerged. This was not a rubble pile comet. This was an object with internal integrity. It behaved more like a sail than a snowball, and that led to a deeper possibility. One that began circulating quietly in classified astrophysics circles, magnetic coupling. It's a concept used in spacecraft engineering. When a craft passes through a variable magnetic field, small electrical currents are induced in its conductive surfaces. These can produce micro-adjustments to orientation or speed, if designed correctly. But magnetic coupling requires conductive surfaces, uniform geometry, and, in many cases, intention. 3I Atlas behaved as though it was built to use that very principle. It didn't resist the sun. It negotiated with it. It didn't shatter under pressure. It flowed with it. And what's more, when the solar storm ended, it stabilized. Its path straightened. Its light curve returned to normal, as if it had absorbed the pulse, stored it, and then coasted forward. That's not a natural interaction. That's a relationship. And it suggests that 3I Atlas didn't just survive electromagnetic pressure, it may have used it. What kind of object remembers the sun? An object built to return to it, or one that came from somewhere that burns even brighter? The labels we give cosmic objects serve a purpose: asteroids, comets, meteoroids. These names help us define what something is and what it isn't. But every so often, something appears that refuses those labels, that breaks the boxes we try to put it in. 3I Atlas is one of those things. From the beginning, it was called a comet. It had a coma. It had a tail. It glowed with outgassed vapor and reflected sunlight. On paper, it looked like a classic long-period comet, except for one key difference. It wasn't bound to our sun. It came from interstellar space, a visitor, and in the early days that label seemed good enough. But slowly, the data piled up. It didn't tumble like a comet. It didn't outgaze in random jets. Its tail didn't simply point away from the sun. In some observations, it pointed toward it. The material it released was controlled, not chaotic. Even its emissions occurred with structure and timing, and every time astronomers looked closer, the illusion of just a comet began to dissolve. The change began with the behavior during perihelion. Most comets shed material wildly when near the sun. Some disintegrate entirely, cracking under the heat and pressure, but 3I Atlas maintained coherence. Not only did it survive, it emerged brighter. Smoother, more refined. It didn't behave like something that barely made it. It behaved like something that was built for it. Then came the trajectory shift. Clean, measured, without spin. The kind of motion that suggests propulsion, but without a visible engine. No exhaust, no flare, no impulse we could detect. It moved like a sail in light wind, except the sail wasn't visible, and the wind was solar pressure. That's when a quiet consensus began to form among a handful of researchers. 3I Atlas was not behaving like a natural object at all. It was executing a series of reactions, aligning with the solar wind, reflecting light from specific surfaces, adjusting direction at precise intervals. It wasn't reacting randomly, it was responding purposefully. Still, most of the scientific community held the line. No anomalies had crossed the threshold into undeniable evidence. But outside those official statements, the private conversation shifted. Engineers started modelling its motion using spacecraft dynamics, not cometary mechanics. Space physicists began reviewing the object's shape based on reflection angles, rather than nuclear spin. The tools changed, because the behaviour no longer fit the category. One of the strongest clues came from polarised light data. Typically, light reflecting off dust scatters in every direction. It's messy. But 3 Atlas showed segments of light that were polarised in a linear direction, as if reflecting off flat or curved metallic surfaces. Not ice, not dust, something denser, more structured, something that retains its form under intense solar radiation. At that point, the theory of natural origins was no longer the simplest explanation. Because natural comets don't hold formation during a solar storm. They don't change course without torque. They don't flare and stabilise with exact precision. They don't emit material toward the sun, deliberately and to gain speed. And they don't maintain structural integrity through temperatures that should destroy any known ice-based body. 3I Atlas began to look less like a snowball from another star system, and more like a system itself. Something with internal logic. Something that operates under control, not just under pressure. So what do you call an object that behaves like a comet, but performs like a probe? You stop calling it a comet at all. You call it what it is, unknown, and unknowns demand attention. Because whatever this thing is, it's teaching us to question what we thought space was made of, and who, or what, might be using it. In 2017, something entered our solar system that no one could explain. Long, fast, silent. It tumbled erratically, showed no tail, emitted no detectable gas, and yet it accelerated. Slightly, deliberately, in ways that didn't fit the physics of ice, dust, or pressure. We named it Oumuamua, meaning scout or messenger in Hawaiian. It was the first interstellar object ever observed passing through our solar system, and for years we didn't know what to make of it. Some said it was a comet without a coma, others claimed it was a flattened shard of rock. Some proposed more exotic explanations, a solar sail, a fragment of alien tech, or an automated probe. But without clear data, the debate collapsed into speculation. Oumuamua passed us quickly, too fast for meaningful imaging and too erratic for follow-up. So we moved on. Then came 2I Borisov, and now 3I Atlas. And suddenly, researchers began to look back. They reopened the old files on Oumuamua. They ran simulations, compared light curves, cross-referenced trajectories, and when they laid that data beside 3I Atlas's behaviour, something chilling emerged. It wasn't just that both objects were fast, interstellar, and mysterious. It was how they interacted with solar forces. Both Oumuamua and 3I Atlas experienced anomalous acceleration, changes in speed not caused by gravity. But neither showed the kind of erratic motion you'd expect from outgassing. There were no torque signatures, no cometary spin-up, no coma rotation. The adjustments were smooth, like course corrections, like responses. And both objects shared something even more unusual. a delayed thermal response. In Oumuamua's case, it warmed too slowly. It didn't react to sunlight the way a comet should. Instead of a rapid flare of heat, it absorbed radiation for hours, and then suddenly changed brightness, as if something had shifted internally. A layer rotated, a material shed, but not in a natural way. 3 Atlas did the same, but with far more precision. It remained stable under solar radiation. Then, after a brief increase in solar wind activity, it flared in brightness and shifted trajectory. Not instantly, not chaotically, but rhythmically, as though something internal had reached a threshold and acted. When the data from both events was compared side by side, astrophysicists noticed timing patterns. The acceleration curves followed similar shapes: a rise, a plateau, a soft taper. That's not the signature of sublimation, that's the signature of regulated thrust. The light curves were also similar, not in brightness, but in modulation. Both showed polarization effects inconsistent with random scattering, indicating structured surfaces, reflective geometry, not jagged dust clouds, but coherent planes. This is when the term behavioral match entered the conversation. 2 separate objects, years apart from possibly the same interstellar region, both exhibiting behavior consistent with something more advanced than nature. Both operating under quiet, delayed reaction curves, both avoiding spin, avoiding destruction, and exiting our system cleaner than they entered. And then came the final clue: the trajectories. When reverse-modelled through galactic coordinates, both 1A Oumuamua and 3I Atlas trace back through the same sector, the same cold void between Cassiopeia and Perseus, slightly offset but flowing along a narrow spatial corridor. The odds of that being coincidence? Less than 1 in 100 million. It means one of 2 things. Either our solar system is sitting in a rare alignment, a gravitational attractor pulling in anomalies from a specific direction, or we're in the path of something intentional, a path that began with a scout in 2017, and now delivers more. The data once dismissed from Oumuamua wasn't incomplete, it was just waiting for context, and now, with 3I Atlas, we may finally understand what that first visitor was trying to tell us. The message was never in the light, it was in the pattern. In space, silence is normal. But sometimes, silence hides a signal. And when 3I Atlas drifted into its mid-approach arc between Jupiter and Earth, researchers didn't expect much. No major flaring, no tail spike, no explosive ejection of dust. Its visible trail remained cold, dim, quiet. But beneath that icy stillness, instruments lit up. Infrared telescopes at the Atacama Desert Array in Chile detected something curious. Subtle thermal echoes bouncing from a direction inconsistent with the solar vector. These weren't reflections from the sun, they were short, scattered pulses, as if a warm object was passing through the comet's tail, heating particles from the inside out. Normally comets shed heat in a linear decay as they move away from the sun. But 3I Atlas didn't just cool, it fluctuated. Small pockets of warmth would spike briefly, then vanish. Instruments ruled out solar flare events or cosmic rays. The pattern was too local, too targeted. So scientists tuned in. Microwave arrays began scanning the tail itself, not just the comet's core, looking for signs of particle interaction. And that's when it got stranger. They found emissions. Low-band, highly modulated electromagnetic pulses were emanating from within the cold trail of 3I Atlas. Not broad-spectrum noise like static, but tight, precise waveforms with repeating harmonics. The kind of waveforms you'd expect from engineered signals, or natural structures behaving with unnatural rhythm. The emissions weren't continuous. They pulsed, every 19 minutes and 43 seconds on average. And each pulse wasn't identical. The waveform shifted slightly with each cycle, as if it was iterating, updating, reacting. At first, skeptics suggested internal friction, materials within the comet rubbing or compressing as it moved, but the pulse intervals didn't align with spin or thermal cycles. 3I Atlas wasn't rotating rapidly. Its mass was distributed evenly enough that stress-based pulses would have dampened over time. These didn't dampen, they amplified. And with every burst, more ionization appeared downstream. Charged particles in the wake began to cluster in unusual formations, thin ribbons of plasma that held shape for seconds longer than expected. In normal comets, ion tails spread wide and fast. But here, some of those ribbons cohered, they aligned, and they pointed not away from the Sun, but occasionally toward Earth. One astrophysicist from JPL described the effect as a language without sound. Something was organizing matter, not violently, but delicately, like a painter tracing invisible strokes in cold air, or a device broadcasting structure into the void. Eventually, NASA retasked its Deep Space Network antennas, the same ones used to communicate with Voyager and Mars probes, to quietly observe these emissions, and what they saw confirmed the strangeness. Between the microwave bursts there were gaps, windows of perfect electromagnetic silence. No background scatter, no cosmic static, just nothing. And then, right on time, another pulse would arrive, clean, structured, like a metronome running in vacuum. Other observatories joined in, India's GMRT, South Africa's Meerkat, the new Japanese MWIN array. All confirmed the signal, all noticed the harmonic pattern. It wasn't a fluke, it wasn't a glitch, it was deliberate. And then came the final twist. During one observation cycle, a faint countersignal was detected, from Earth, not transmitted but reflected. One of the pulses appeared to bounce back, caught by satellites orbiting near geostationary position. It wasn't strong, but the timing was perfect. The emission from 3I Atlas had intersected with Earth's magnetosphere at just the right angle to return a faint echo. That should be impossible. Cometary trails don't create radar. They don't behave like antennas, unless they're more than trails, unless they're instruments themselves, designed not just to travel, but to listen. In the icy dust behind 3I Atlas, the cold leaves no clue, but the signals, they burn hot, and they might not be for us, they might be from us, echoed back by something that was always listening. Not all anomalies are new. When the 3I Atlas trajectory was first confirmed to intersect near Earth's orbit, researchers naturally plotted its alignment patterns, solar angles, planetary shadows, gravitational tides. But what few expected was that this alignment had happened before, not just once, but with eerie consistency, every 7,111 years. The James Webb Space Telescope had recently released deep infrared comparative data on interstellar comets, including pre-solar system object pathways. When matched against ancient orbital simulations, 3I Atlas showed a haunting match, not in its full trajectory, but in its precise alignment with three celestial bodies, Earth, Jupiter, and the Sun. This triangle wasn't random. In ancient Sumerian astronomy, a tripoint configuration between a comet, the Sun, and Jupiter was referred to in cuneiform tablets as the furnace gate, a symbolic opening in the sky associated with omens, upheaval, or transition. The same tablets noted the appearance of a flaming traveller crossing the sky in cycles of roughly 7,000 years. Most dismissed these as mythological poetry, but the orbital math no longer allowed that luxury. At the exact moment 3I Atlas began its closest approach to Jupiter's Lagrange shadow, Earth entered its equinox zone, a balance point between night and day. And during that 72-hour window, Atlas formed a perfect 180-degree solar opposition line with Earth, reflecting not just light, but gravitational focus. It wasn't just aligned, it was centered. Radio observatories recorded a sharp drop in deep space background noise in that moment. Frequencies in the 14 GHz range, typically clogged with cosmic microwave background hum, fell into a narrow trough of silence. It was as if something had created a lens, a tunnel, or a filter. Solar observatories also noticed a peculiarity. Sunspots near the equatorial zone clustered unusually close together, forming a filament shape aligned with Atlas's trajectory. Solar physicists called it a coincidence. But one noted in a now archived internal memo that the sunspot configuration resembled the structure of magnetic flux ropes, the same phenomena seen in coronal mass ejections, and the timing? It matched exactly with the triangulation window. But the deeper mystery came from ancient Earth. Archaeologists working with LiDAR in Central America unearthed a series of stone discs buried beneath a collapsed temple site in Guatemala. The discs were not written in known Mayan glyphs. They contained astronomical pictographs, star shapes, comet trails, and angles between three spheres. The arrangement mirrored the 3i Atlas triangle. The final disk showed a spiralling line connecting the three bodies, ending in a fourth circle marked with concentric waves, the symbol for vibration, for signal, for communication. No carbon dating was possible due to the material, a black volcanic glass compound, but nearby organic matter suggested a date range between 5,000 and 7,500 years ago. So now the pieces began to align, a comet that repeats every 7,111 years, ancient records predicting a three-body alignment, telescopic evidence confirming a gravitational funnel, and archaeological symbols suggesting a fourth point, a response, a receiver. Some researchers went further. They began whispering the word resonance, the idea that 3i Atlas wasn't just crossing space, but triggering something, a hidden pattern in the solar system's structure that only activated under exact alignments. Resonance structures are not new to science. The Moon's orbit is tidally locked in perfect resonance with Earth. Saturn's rings exhibit spiral density waves triggered by its moons. Jupiter causes Trojan asteroid swarms to align in gravitational sync. What if 3i Atlas was part of something larger? A planetary metronome, a cosmic marker, a seed, and every time it returns, the system responds. On this pass, for the first time in history, we have the tools to see it happen, to measure, to record, to interpret. But the danger is this: if it's a signal, we might not be the intended audience. Most comets release gas and dust chaotically. Their icy nuclei heat up under solar radiation, causing surface vents to erupt, blasting water vapor, carbon monoxide, and other volatiles into space. These jets are random, unpredictable, and usually isotropic. But 3i Atlas has never behaved like a normal comet. In the final 48 hours of its closest approach to Earth's orbital plane, something unexpected re-emerged. From observatories in Chile and Hawaii, both equipped with near-infrared adaptive optics, came confirmation of a distinct phenomenon last recorded weeks ago: two ultra-fine jets, fired not from the nucleus at random, but from symmetrical points on the comet's rotational axis. Not only were they straight and narrow, but they pivoted, adapting their angle slowly, as if compensating for external forces. This wasn't the first time this had happened. During Atlas's perihelion, solar proximity melted large amounts of surface ice, releasing the usual outbursts, but also revealed these directional jets. Back then, scientists assumed they were short-lived anomalies, possibly a result of buried subsurface vents exposed during solar flyby. But now, after distance from the Sun should have cooled the nucleus significantly, the jets were back, and this time they were stronger. High-resolution imaging from the European Space Agency's Solar System Watch program showed the jets pulsing, not in continuous emission, but in rhythmic bursts. Each burst lasted exactly 2.6 seconds, then paused, then repeated, like a heartbeat or a transmission. Their orientation was even more perplexing. Rather than pointing away from the Sun, the standard direction of most cometary activity due to solar wind, the jets were angled toward Jupiter, not in a vague curve, in a line, a trajectory line. The comet was actively correcting its course. The math became clear when trajectory analysts at NASA's JPL ran new simulations. Based on the orientation and duration of the jets, Atlas had made 3 minor but measurable trajectory changes, course corrections that veered it closer to the gravitational envelope of Jupiter's magnetosphere. This wasn't a passive object drifting through space, it was navigating, and there was more. Spectral analysis of the jets revealed something no one was ready to admit: trace compounds of niobium and zirconium, elements not usually associated with cometary cores and far rarer in known natural concentrations. Both are highly conductive, with unique refractive properties at high temperatures. When ionized, they can reflect specific radio frequencies. In short, they behave like antennae. Researchers debated the data in closed briefings. Some called the jets evidence of crystalline structures deep within the core, perhaps formed under ancient supernova pressures. Others, more cautiously, questioned whether Atlas had internal architecture, a configuration that not only contained exotic metals but knew how to use them. Then came the triangulation. Radio telescopes in Spain, California, and Australia, part of a global array, each detected synchronized diffraction spikes when the jets aligned directly with their receiver coordinates. For 8 seconds, All 3 stations recorded sharp signal interference, not random, not white noise, but an artificial pattern, binary sequences, short, looping, repeating. At first it was dismissed as Earth-based contamination, but when the jets pivoted and pointed elsewhere, the interference stopped. When they returned, the sequence resumed. Atlas was beaming. To what, no one knew, and the implications were staggering. For the first time in modern astronomy, a comet was not just reflecting light, not just emitting gas, but pointing energy, intentionally. Some said it was a kind of cosmic Morse code, a slow, simple language meant for receivers not bound to human speed or cognition. Others weren't so optimistic, because if Atlas was a transmitter, it meant someone or something might be listening. And they'd just heard Earth pick up the signal. The phrase came from a junior astrophysicist at the Instituto de Astrofísica de Canarias. As she stared at the spectrographic readout from Atlas's core emissions, she muttered, "These are echoes of something that already died." At first her comment was brushed off. Poetic, perhaps, but not scientific. Yet within hours, senior researchers would echo her words in hushed tones. Because the energy signature radiating from the inner layer of 3I Atlas bore eerie resemblance to the remnant frequency of a supernova. Specifically, SN Tesseract, the Crab Nebula's parent. To understand how bizarre this was, one has to understand what a supernova echo is. When a star dies in a cataclysmic explosion, it not only releases light and gas, but sends out high-energy photons that can scatter off interstellar dust clouds for centuries. These scattered photons, arriving delayed due to their longer travel paths, can still be picked up as dim, ghostly flashes long after the star itself is gone. But those echoes are seen in nebulae, clouds of gas and dust, not frozen cometary bodies, and certainly not inside something less than 10 kilometers wide, but the inner shell of Atlas, that dim, pulsing ring barely visible under high-contrast infrared imaging, radiated in a frequency spectrum almost identical to historical remnants of SN 1054. The resonance wasn't a perfect match. It was distorted, compressed, like a playback. This prompted astronomers to run deeper frequency decomposition, breaking the waveforms into individual harmonic layers. What they found was even stranger. Embedded within the base signal were periodic spikes, precisely spaced at 13.7-minute intervals. These weren't random, they matched the decay pattern of a neutron pulse, which made no sense. Neutron pulses can't be stored, they're events, not signatures, and yet the pattern persisted, over hours, over days, always pulsing at 13.7-minute cycles, as if something inside Atlas was recreating the rhythm of a stellar death. But why? And more importantly, how? To probe further, a team at the Max Planck Institute ran polarization tests on the core's emissions. They expected chaotic output, standard for any natural object emitting thermal radiation. But Atlas's output was polarized at a consistent angle, 41.3 degrees off-axis, and stayed that way even as the comet rotated. The only known sources of persistent polarization at fixed angles, man-made lasers and some neutron star emissions. Now the phrase "echoes of a dead star" didn't feel so poetic anymore, it felt literal. That raised 2 disturbing possibilities. Either Atlas was somehow carrying preserved material from a star that exploded over 900 years ago, something astronomically unlikely given its interstellar origin and lack of known trajectory near SN 1054, or it was imitating that echo, replaying it. Which begged a terrifying question. Was Atlas a recorder? Had it been designed, or evolved, to store the death throes of stars? If so, it meant 2 things. First, it had been present at the scene of stellar collapse, possibly more than once. Second, it had a reason to carry those echoes through space. One theory, proposed quietly among astrophysicists at Caltech and Tokyo University, was that these emissions could serve as a kind of galactic warning system. A breadcrumb trail of cosmic extinction, left behind like audio recordings of dying stars, not for nostalgia, but for navigation, so that others could find, or avoid, the paths of death. But this theory was soon followed by another, darker one. What if Atlas wasn't broadcasting a warning, but a signal to return? What if the echo wasn't for others, What if it was for itself? A calibration tone, a homing beacon, a reminder of where it had been and where it was going. And then came the discovery that changed everything. From a small observatory in Argentina came the image. The polarization angle of Atlas had shifted, slightly. Now it was 41.3 degrees toward Earth. It started as a statistical anomaly, just a subtle deviation in the angle of Atlas's emissions. But in science, the smallest shift can signal the biggest threat. For weeks, the polarization angle of 3I Atlas's internal radiation held steady at 41.3 degrees off its axial rotation. It was like a fixed spotlight, illuminating nothing in particular, just marking some internal logic, or perhaps a memory of where it had been. Until the angle changed. On the morning of December 22nd, analysts at the Argentine Cerro Tololo Observatory noticed the beam had moved by 2.1 degrees, subtly but unmistakably, now pointing directly toward Earth's position in space. At first, the update went unnoticed. Polarization shifts happen all the time in stellar bodies due to rotation, dust scattering, or orbital drift. But what made this different was that the shift didn't wobble or decay. It was precise, purposeful, as if it had recalibrated its beam mid-flight. Within 12 hours, 3 more observatories independently confirmed the same measurement. The emission was locked on Earth. Now, this alone wouldn't raise alarms. Comets often point tails or jets toward the sun due to solar wind. But this wasn't a tail, and it wasn't ionized gas. It was information-bearing radiation. That was the phrase used in the emergency report issued by the Max Planck Institute. The beam contains layered harmonics that demonstrate information-carrying structure. This is not noise. When mapped against historic electromagnetic patterns, the beam shared properties with L-band radar, specifically those used in early satellite communications. But it didn't just match communication frequencies, it mimicked targeting patterns. The structure of the emission contained pulsed locks, microbeacons, and alignment corrections, all hallmarks of an active scanning system, the kind used in Earth's most advanced spacecraft and orbital defense simulations, which meant one thing: Atlas was tracking Earth, not passively, actively, and the implications sent waves through the international scientific community. Private encrypted meetings were called between NASA, ESA, JAXA, and the Chinese CNSA. Even the Indian Space Research Organisation quietly joined the loop. Every agency had one question: is Atlas targeting Earth intentionally? Some argued no. It could be coincidence, a magnetic anomaly aligning with Earth's dipole. Others were less optimistic. They pointed to the growing list of engineered behaviours: directional jet bursts, symmetrical energy pulses, gravity countermeasures, and now, this. What made it even more chilling was the rate of alignment. By 1820 UTC that day, the beam's angle had narrowed from 2.1 degrees to 1.7. It wasn't just pointed toward Earth. It was refining its aim. High-gain telescopes from the ALMA array were reoriented to isolate the structure of the beam. What they detected was more than just electromagnetic alignment. It was temporal synchronization. The beam's pulses matched the timing of Earth's rotation and orbital motion, adjusting for our planet's movement in real time. It was predictive. That was the turning point. Because something predictive is not reactive. It implies a model, a simulation, something, or someone, that knows where Earth will be in 5 minutes, or 5 days. And then the question emerged: if it's watching us, what happens when it arrives? That same evening, the French satellite Le Croix 3 caught an image that no one could explain. A secondary emission, a faint spike of radiation, had emerged from Atlas's side. This was not part of its usual activity. It wasn't chaotic, it was geometrically perfect. A right angle, forming a secondary vector, not just toward Earth, but toward Earth's magnetic north, which meant Atlas wasn't just targeting our planet, it was aligning with our field, not randomly, not slowly, but smoothly, with a kind of confidence only seen in pre-programmed systems. And that raised one final question. Why does it need to align with Earth at all? Was it mapping our field? Was it calibrating something? Or was it preparing for contact? The Earth has always had a shield, an invisible armour of magnetism stretching tens of thousands of kilometres into space, deflecting solar winds, coronal mass ejections, and galactic radiation. Without it, the planet would be sterilized by the sun. The magnetosphere is, in many ways, Earth's first line of defense, a dynamic, responsive force field generated by the churning molten iron of our outer core. So when 3I Atlas began aligning with that field, a different kind of panic set in. Not because it was emitting raw force, but because it was interacting with our planet's most sacred boundary. Not physically, but magnetically. Silently, calculated. On the evening of December 22nd at exactly 21:09 UTC, 5 magnetometers across the equator, from Quito to Kinshasa to Singapore, recorded a synchronized microdistortion in the Earth's geomagnetic field. At first, it looked like a solar anomaly, perhaps a subtle pressure wave from a distant flare. But solar data from SOHO and the Parker Solar Probe confirmed there had been no solar activity in that window. Something else had caused the breach, and it matched, perfectly, the arrival time of a faint secondary emission from Atlas. This wasn't just alignment, it was field penetration. According to data from the Van Allen probe still in limited orbit, the magnetosphere didn't just ripple, it tightened, as if something had reached in and grabbed it. The inner belt, composed primarily of high-energy protons, showed a momentary phase compression. Scientists from MIT described it as a magnetic clench, localized and precise, without corresponding atmospheric disturbance. In other words, Atlas had found a way to touch our magnetic shield without breaking it. That's not something comets do. They don't care about the magnetosphere. They don't notice it, and they certainly don't interact with it as if they understand its structure. But that's exactly what Atlas was doing. The breach didn't last long, 4 seconds, according to the instruments. But during that window, ground-based detectors across Alaska and northern Canada picked up something even stranger, a mirror pulse, a return signal, a low-frequency reflection that matched the inbound emissions profile but had been altered, subtly, as if Earth's own magnetic shell had been encoded in the return. NASA's interpretation was immediate. The field has been scanned, and not just passively. The pattern matched active radar mapping, the kind used by terrain-penetrating instruments, but instead of soil or rock, it had scanned our defense field. That alone would have been historic, but what followed was worse. 20 minutes later, a new anomaly appeared in the thermospheric plasma around the equator, an organized ring of heat, rising from baseline temperatures by over 80 Kelvin in less than 5 minutes. This ring was shaped not by solar interaction, but by constructive resonance. Atlas was using harmonics. It had figured out the rhythm of our magnetosphere and begun to sing to it, a literal resonance match, using waves timed to our own planetary pulses. And that's when the hypothesis changed. Atlas wasn't just breaching the field, it was communicating with it, or worse, calibrating to it. Some theorized that this was a prelude to physical contact, that aligning with Earth's magnetosphere would allow the object to land, enter, or transmit with minimal resistance. Others feared something more abstract, that Atlas wasn't trying to come to Earth, it was trying to make Earth part of its system, just like a docking procedure, by aligning with the field, synchronizing pulses, scanning the belts, and resonating with the thermosphere. Atlas was doing what no natural object had ever done, treating the magnetosphere not as an obstacle, but as an interface. The implications were massive, because if Earth's magnetic shield was being turned into an input device, then it meant Atlas wasn't just active, it was interactive. And the question no one wanted to ask was this: if Atlas can reach into our magnetosphere, what else can it access? In the hours following the magnetic field scan, the atmosphere grew quiet, unnaturally so. For centuries, scientists have known that even minor interactions with Earth's upper layers leave behind some kind of turbulence. Whether it's solar radiation, high-altitude lightning, or human-made interference, the result is always measurable: auroras, ionospheric refraction, ELF waves. But not this time. After 3 Atlas touched Earth's magnetosphere and withdrew, it left behind no light, no sonic boom, no electromagnetic distortion, only heat. A strange, circular bloom of heat. It was first detected by Japan's Hisaki satellite, which monitors extreme ultraviolet emissions from the thermosphere. What the team saw was so unexpected they initially suspected a sensor fault, a perfectly symmetrical ring of heat expanding at high altitude, moving at a steady rate, with no meteorological or solar explanation. Rings in the thermosphere aren't natural. Especially not ones this stable. The ring expanded outward from the equator, spanning nearly 300 kilometers within the first 17 minutes. It rose in temperature from background levels of 1200 K to over 2100 K. Not enough to affect life on the surface, but enough to warp satellite readings, disturb GPS signals, and create phantom echoes in radar systems across the globe. The heat didn't come from below. It came from above, as if injected silently into the atmosphere. Unlike traditional thermal events which radiate unevenly, this ring was uniform, smooth, designed. The silence that followed was even more chilling than the event itself. In the South Pacific, the HAARP system in Alaska picked up a curious absence of VLF, very low frequency, wave activity in the area around the ring. Normally, the Earth's upper atmosphere crackles with invisible energy, background chatter of our electrically alive world. But now, it was as if someone had hit the mute button. The thermosphere wasn't just warming, it was listening. What exactly it was listening for remains unknown. But many researchers, including private contractors from ESA, began modelling the heat bloom as a signal receiver rather than a transmitter. The hypothesis? Atlas had installed a kind of temporary dish in our atmosphere. Think of it like dropping a hydrophone into the ocean, not to transmit sonar, but to hear what's moving beneath the waves. Except this wasn't water, it was the edge of space, and something was listening. The ring's symmetry began to destabilize 6 hours after formation, not due to weather, but because of a second, weaker ring that began to form 1,100 kilometers north, near the mid-latitudes over the Pacific Ocean. This second ring was cooler, about 900 K above baseline, but it pulsed in intervals. Every 38 seconds, a faint drop in density could be measured, followed by a rebound. This oscillation didn't match known atmospheric tides or magnetic cycles. It matched a heartbeat. The pattern resembled the electromagnetic pulses emitted by large organisms. Not metaphorically, biologically. A cardiac-like rhythm, superimposed on the thermospheric layer, as if the atmosphere itself had been momentarily synced to something alive. Some theorists immediately rejected the notion, but others, like Dr. Aaron Malik of the Atmospheric Mapping Initiative, proposed a stunning idea. We may be looking at a system calibration event. The ring isn't just a heat signature, it's a biological mimicry algorithm. Atlas may be trying to simulate life, or understand it. The implications were staggering. If Atlas was creating thermal rings as sensory mechanisms, and if it was experimenting with biological rhythms, then it wasn't just mapping Earth's atmosphere, it was inhabiting it, not by landing, but by turning our own atmospheric layers into sensory proxies, as if the comet had found a way to embed itself without ever touching the ground. Which raised the next question. If Atlas could do that here, what other atmospheres has it already mapped? Gravity is one of the most predictable forces in the universe. It moves in straight lines, it curves around mass, and it only flows one way, inward, towards sources of mass, towards celestial bodies, black holes, collapsed stars, planets, and anything else with density. But at 0442 UTC, scientists at the Laser Interferometer Gravitational Wave Observatory, LIGO, in Washington, detected something that reversed that rule. A gravity wave, yes, but one that appeared to push outward from a point between Earth and the Moon. That is not how gravity works. To understand how bizarre this is, you have to understand what a gravity wave even is. These are not sound waves or radio signals. Gravity waves are ripples in the very fabric of space-time, often triggered by massive collisions like two black holes spiraling into one another. They travel at the speed of light, stretching and compressing space as they pass. LIGO has only detected a handful of them since 2015, and all from distant titanic events millions of light years away. But this one wasn't distant. It was here. And it wasn't from a collision. It came from a region of emptiness. What LIGO recorded was a low-amplitude, high-frequency pulse originating roughly 30,000 kilometers above the Earth, slightly beyond geostationary orbit and frighteningly close to where 3I Atlas had just passed. But it wasn't coming toward the Earth. It was pushing away from Earth. Not gravitational attraction, but gravitational repulsion. This shouldn't be possible. Gravity only attracts. We have no confirmed evidence that any natural object in the universe can repel other objects gravitationally. Even dark energy, the mysterious force causing the expansion of the universe, doesn't operate like this. And yet, for 2.8 seconds, LIGO recorded a measurable directional shift in space-time curvature, like something had pulsed, pushing the fabric of space outward, not inward. The data was verified by 2 additional instruments, Virgo in Italy and Kagra in Japan. All 3 observatories saw it, and all 3 confirmed that it originated from the same corridor 3I Atlas passed through less than 12 hours earlier. The first hypothesis was error, a miscalibration, a power surge, but internal diagnostics showed nothing wrong. The second theory, a classified military test, but there was no activity from the US, Space Force, Russia or China in that region of space, and certainly nothing capable of generating gravitational distortions. That left only the third possibility. 3I Atlas didn't just pass through our system, it used it. Used Earth's gravity not just as a slingshot, but as an interface, as if it had accessed gravity, reconfigured the way spacetime was behaving in that zone, and fired a pulse back into the void, perhaps toward the sun, or perhaps toward whatever was still behind it, like a message, but not in light, or radiation, or sound. A message written in spacetime itself. Dr. Sanjit Vohra of the Interstellar Metric Project called the event the closest thing we've ever observed to an artificial gravity signature. He added, "If this was intentional, it would imply a mastery of general relativity far beyond anything we can simulate. And if it wasn't intentional, then something about the nature of Atlas is so exotic, it's capable of warping reality simply by moving. The final anomaly? The wave wasn't spherical. It was shaped like a beam, a narrow concentrated push, like a spotlight of gravitational force. With a cone angle of just 17 degrees, it was one of the most focused gravity signatures ever recorded, and it pointed directly at the trailing region of 3I Atlas's own motion path, as if echoing backwards. Whatever Atlas was communicating, it might not have been speaking to us. At 0612 UTC, seismographs across the globe began to hum, but not from an earthquake. There was no tremor, no tectonic movement, no shifting fault lines, and yet, from Iceland to Indonesia, from Hawaii to the Himalayas, deep Earth monitoring stations registered a strange resonance. It wasn't seismic in the traditional sense. Instead of sudden jolts or rolling waves, the signal came as a low-frequency oscillation, a hum buried beneath the crust, too smooth for an earthquake, too coherent for background noise. At first, researchers believed it might be an after-effect from a distant quake. But the pattern was wrong. The vibration had no epicenter, no origin point. It emerged simultaneously on all continents, as if it rose from beneath the entire planet. This phenomenon wasn't just global, it was planetary. The waveform itself was unprecedented, a continuous sine-like pattern repeating every 16.7 seconds, with overtones that resembled resonance chambers in metallic structures. Geophysicists called it structural, not seismic, because it mimicked the behavior of engineered systems. Some even compared it to the harmonic vibrations inside a bell, except in this case, the bell was Earth. The vibration lasted for 6 minutes and 22 seconds. Then it stopped. But what came next was stranger still. One of the most sensitive instruments capable of monitoring subterranean energy exchanges, the Mantle Deep Passive Array in Western Australia, picked up a back echo. Something had bounced, not like sonar bouncing off a cavern. This was a delayed return, a ping that suggested an intelligent signal had passed through the Earth and reflected off something deep and solid beneath the crust, something not normally present in the geological record. This sparked a race between seismic research teams around the world. Within hours, NASA's Jet Propulsion Laboratory cross-referenced the subterranean resonance event with the gravity wave detected by LIGO, which had occurred less than 2 hours prior. What they discovered sent shockwaves through the scientific community. The frequency profile of the underground echo bore a near-identical match to the gravitational pulse that originated from 3I Atlas's corridor in orbit, meaning the two events were connected. Something in orbit pulsed gravity, and then the planet responded, not at the surface, not in the atmosphere, but from beneath the crust. Theories began pouring in. The more conservative hypothesis was that 3I Atlas had somehow disrupted Earth's gravity field just enough to create a resonance event within the mantle. But this didn't explain the coherence of the waveform. Natural disruptions are messy, chaotic. This was precise. Others proposed that 3I Atlas may have interacted with subsurface features of the planet, perhaps even triggered anomalies hidden beneath tectonic plates, ancient impact scars, buried voids, long-forgotten deposits of exotic matter from early solar formation. But one theory stood out, a fringe idea that was quietly passed between researchers in encrypted messages and private calls. What if the Earth didn't just react to the pulse? What if something beneath the Earth recognized it? A scientist at a European Deep Earth Observatory, who requested anonymity, said this: "We've seen minor resonances before, but they don't echo back like this. They don't respond as if something received and sent back. The only thing that fits is a harmonic feedback loop, like when you hit a tuning fork and another one starts ringing in resonance. Only this time the tuning fork was in space. In short, 3I Atlas rang the Earth like a bell, and something, possibly artificial, possibly ancient, possibly hidden beneath miles of crust, rang back." The implications are staggering. It could mean the Earth has dormant structures we've never mapped, or that some materials, possibly non-terrestrial in origin, were seeded deep within the planet long ago and are only now being activated. And if that's true, then 3I Atlas didn't just visit Earth. It may have spoken to it, and the Earth may have answered. At 0740 UTC, a team of lunar observers stationed at Mauna Kea, Hawaii, noticed something off. While reviewing time-lapse imagery of the moon's surface, they detected an irregularity, not in the terrain, but in the shadow. Except it wasn't a shadow. Every 3.6 hours, a faint crescent-shaped darkness began to sweep across the Sea of Tranquility, a subtle veil that didn't follow any known solar or orbital mechanics. It moved against the direction of sunlight. It had no source of occlusion. It simply appeared. For several cycles, the phenomenon was dismissed as a processing artifact, maybe a glitch in the sensor's contrast algorithm. But when identical data began pouring in from Chile's Atacama Observatory and the Lunar Reconnaissance Orbiter, LRO, in low orbit, it became clear. This wasn't a local anomaly. This was real, but it wasn't casting a shadow. It was more like it was siphoning light. High-resolution multispectral scans revealed that the dark form didn't absorb light the way the moon's basalt plains did. Instead, it bent it, like a gravitational lens, only much smaller and much closer to the lunar surface. One astrophysicist described it like this: "It's as if something's draped over a patch of the moon, warping the light around it like a silk cloth over a mirror," and then came the real surprise. The dark crescent began to move, not randomly, not like drifting space dust or charged particles following magnetic paths. This thing had intent. It followed the lunar terminator, the line separating night and day, tracking its movement with eerie precision. It didn't drift across the terrain. It hovered just above it. NASA's LRO thermal imaging systems picked up no heat signature. The object, or field, or shadow, or membrane, was colder than the surrounding regolith. Not by a few degrees, but by an order of magnitude, near absolute zero. To be clear, this was colder than the darkest, deepest lunar craters. That alone defied physics. Some speculated it could be a new form of energy field, a low-frequency gravitational sheet interacting with the moon's surface. Others proposed more exotic theories, that it was a remnant plasma wake from 3I Atlas, or even an autonomous probe using the moon's terrain as camouflage. But then came the strangest part. During one of the passes, as the crescent-shaped field slid over the Apollo 11 landing site, it paused, just for 38 seconds. Long enough for the instruments to register a spike in neutron reflection. That means something in the shadow emitted particles, not randomly but in a brief controlled burst. Enough to bounce off the surface and be detected by instruments not even aimed directly at the event. Then it resumed its motion. No heat, no mass, no sound. But a neutron burst at the most symbolic location on the moon, a location where the first human set foot. Some called it coincidence. Others believed it was intentional contact. A few voices inside the European Space Agency quietly referenced a theory that had circulated since the early days of 3 Atlas observation. that the object may be broadcasting across gravitational substrates, using reflective surfaces, like the Moon, to echo those signals across multiple planetary bodies. But now the idea was more extreme. What if the crescent wasn't broadcasting? What if it was collecting? Lunar dust samples from past missions contain exotic isotopes with origins traced back to supernova remnants. That means the Moon, unlike Earth, retains particles from ancient cosmic events due to its lack of atmosphere. What if 3I Atlas, or something it deployed, was skimming the Moon not for cover, but for information? The motion of the shadow, the neutron spike, the location. The cold field that left no trace but left a message, one that scientists are still deciphering. What if the Moon itself, long thought to be lifeless and silent, just responded to a query it has waited eons to receive? At exactly 0814 UTC, magnetometers across the Northern Hemisphere began registering a localized distortion in the Earth's magnetic field. At first, it was mistaken for routine solar interference, a spike in auroral activity, maybe a minor coronal mass ejection brushing against the magnetosphere. But when the signal refused to dissipate, and instead began spiraling inward, researchers knew they were looking at something unprecedented. The first full-field map came from ESA's Swarm constellation. 3 satellites, Alpha, Bravo and Charlie, confirmed that the anomaly wasn't global, it was focused, tightly localized. Hovering over the North Atlantic, somewhere between Greenland and Iceland. The distortion resembled a whirlpool, not in water, but in magnetic flux. But the magnetic lines weren't being pulled upward, as in a typical polar storm. They were being dragged downward, into a spiral, into a point, and then into a hole. Satellite visualization showed something even stranger. The spiral wasn't chaotic, it followed a mathematical pattern, the Fibonacci sequence to be exact. A golden spiral forming over Earth's upper magnetic shell, like an invisible drill turning through space-time. This was no random twist of magnetism, this was engineered behavior. Scientists from the Goddard Space Flight Center released a preliminary model just 3 hours later. The data revealed that the spiral was drawing field lines into a region just 400 kilometers above sea level, low enough to disturb satellites, but too high for any known Earth-based technology to affect it. Even stranger, every 6 minutes the spiral would reverse direction, pulling magnetism back outward in a slow, pulsing wave. It was behaving like a breathing organ. In, out, in, out. But here's what froze the entire geophysics team. The spiral's pulsing matched the neutron burst detected on the Moon just 34 minutes earlier. This wasn't just a geomagnetic event, it was synchronized, and it didn't stop. By the time midnight approached in UTC, the spiral had expanded. It was no longer confined to the Atlantic. It began to stretch over parts of Europe, Iceland, Scandinavia, even parts of northern Russia. Airline traffic was rerouted due to magnetic compass interference. Communication systems began to behave erratically. Satellites orbiting through the spiral's field began experiencing attitude instability, as if their internal gyroscopes couldn't decide which way was down. And then came the visual component. Pilots flying over the polar routes reported a previously undocumented phenomenon. Streaks of faint, spiraling light, like thin auroral ribbons but not green or red. These were blue-white and moved independently of Earth's ionospheric activity, like tendrils from something invisible, reaching downward. Observatories tried to capture the ribbons in long exposure. One frame from a station in Finland finally caught it, a double helix spiral of faint light, arcing down from the thermosphere to just above the cloud layer. A structure with symmetry, with motion, with purpose. Now came the question no one wanted to ask. Was this a natural response to 3I Atlas's electromagnetic footprint? Or was this created by the object, perhaps a tethered mechanism extending influence toward Earth? If so, it meant one thing. 3I Atlas wasn't just passing through, it was interfacing with magnetic systems, with gravity, with the Moon, with Earth. The spiral hole was only the beginning. What it was channeling, or anchoring, remained undetected. But one observation terrified the swarm team most. For every outward spiral, every time the field exhaled, Earth's total magnetic intensity dropped. slightly, measurably, not just locally, but globally, as if something was siphoning the field strength pulse by pulse, not enough to trigger collapse. Not enough to cause catastrophe, but enough to leave a fingerprint, a draining effect, a test, or worse, a signal back. By Astro 3:37 AM UTC, sky watchers from Canada to Croatia were reporting the same thing. Lightning, but from clear skies, no clouds, no humidity, no storm systems on radar. And yet bolts of white-blue electricity cracked down from the upper atmosphere, touching rooftops, forest edges, and mountaintops. In the deserts of Arizona, static electricity danced along dry sand like it had just rained. In Sweden, an entire field of wheat glowed faintly blue, then flickered with bursts of light that cracked through the ground. And there wasn't a single cloud in sight. At first, meteorologists scrambled to explain it. Perhaps it was dry lightning, a rare event during heat waves. But these weren't isolated bolts. In some areas, they lasted minutes, threading across the sky horizontally, then looping back down in erratic arcs. They were symmetrical, organized. NOAA's geostationary satellites registered multiple discharges, but the source wasn't inside Earth's troposphere. It was coming from above, specifically the mesosphere, over 50 kilometers up. That's where something even more bizarre was seen. An array of blue sprites, gigantic electrical bursts that usually happen during intense thunderstorms, began appearing without any thunderstorm activity. But they weren't random. They were geometrically patterned, forming grids, rings, even symbols, some resembling spoked wheels or fractured circles. It was as if the atmosphere was responding to a code. Electricity wasn't just discharging, it was shaping itself. The European Space Agency cross-referenced the events with the ongoing electromagnetic spiral in Earth's magnetic field. The timings matched exactly. Each time the magnetic spiral breathed out, a cluster of these cloudless electrical storms would ignite. And this wasn't just visual. Sensitive electric field meters in rural Montana began overloading from ground-level charge buildup. People could feel their skin tingle, the kind of charge you feel before touching a metal door handle in winter, but constant. Pets refused to walk across carpets, hair stood up for hours, and when some people tried to touch their smartphones or metal railings, they were zapped with voltages high enough to leave small burns. This was planet-wide static accumulation, but the most disturbing part came from the mountains of Tibet. An international team of geophysicists had been studying ball lightning phenomena when they noticed something terrifying. A sphere of light hovering 6 feet above the ground, spinning, humming, but motionless. It didn't drift like typical ball lightning. It stayed centered, balanced, until it split into 3. Each orb zipped silently in a different direction, then exploded into a flash of light that sent shockwaves through the valley. Not explosive force, but a pressure wave, electromagnetic in nature, like a pulse. The next morning they reviewed the footage. The orbs weren't just glowing. They were oscillating, alternating light intensity at exact intervals, 3.3 Hz, then 6.6, then 9.9. The same pattern seen in previous 3 Atlas energy bursts. Once again, this wasn't coincidence. This was communication. But from what? And then came the data from Japan's upper atmosphere balloon array. Their sensors had captured faint radio emissions during each sprite burst. The signal wasn't natural. It contained structure. And inside that structure, pulsing under the bursts, was a repeating 3-tone harmonic, a musical interval, not static, not interference, a melody. This wasn't just a storm, it was a performance. But for whom? As the hours passed, electrical activity surged along fault lines in California and Chile. Electrons flowed across normally dormant rocks. Deep crustal sensors picked up tremors, not seismic, but electromagnetic tension. Something was charging the Earth's crust itself, and geologists feared what might happen if that charge released. No clouds, no rain, just the hum of power coursing through land, air, and water, all without a single storm on the horizon, just the echo of something bigger, watching, testing, playing with Earth's charge as if tuning an instrument. The planet had become a conductor, and the song was just beginning. At 04:12 AM UTC, astronomers in Australia saw it first. The anti-tail of 3I Atlas, once fanning gently away from the sun in perfect alignment with solar radiation pressure, began to move. Slowly, almost imperceptibly at first, the faint stream of dust and ionized particles began to curve. But not in response to solar wind or gravitational forces. It was curving against them, and not randomly. It was pointing back toward Earth. This wasn't how anti-tails behaved. In every known case, cometary anti-tails are visual illusions, the result of Earth's perspective slicing through a broad, thin dust sheet. But this wasn't a trick of light. Infrared sensors confirmed it. So did Lyman alpha spectral data from Japan's Kaguya satellite. The anti-tail was physically reorienting,